So how does the idea of evolution appear in astronomy? When Darwin was young, most of the effort in astronomy was simply to describe what could be seen. The basic structure of the solar system was understood. The disk-like structure of the Milky Way galaxy, in which the solar system is located, was already recognized and beginning to be explored in detail. It would be much later, however, in fact in the 20th century, before the recognition of the existence of other galaxies distributed through a much vaster space had been recognized, would become accepted. Gradually, throughout the 19th century in which Darwin lived, the ideas of the physical sciences were beginning to be applied to astronomy. And it was realized that these sciences could give a much more complete description of the nature of stars and galaxies than had been possible before. These descriptions were so detailed that one could begin to move from the question how to the question why. The question of how does the universe look began to be supplemented by questions such as why does the universe look like that? How did it come to be? How did it start? How did it evolve? In fact, the word evolution is in common use in astronomy. With the improvement in our understanding of the physical sciences throughout the 19th and 20th century, these questions were no longer merely idle speculation, but were capable of serious investigation. The present conclusion of astronomy is similar, in my view, to that of biology. Planet Earth is not detached from the rest of the universe. We are not mere observers of the universe, we are part of it. Just to illustrate what I mean by this, I'll discuss very briefly three aspects of evolution in astronomy. Firstly, the origin and evolution of the universe at large, then the evolution of stars, and finally, the formation of planets on which life could evolve. On the largest scales, we see a universe of clusters of galaxies. These clusters are moving away from each other, suggesting that the universe began in a highly compressed and very hot state. We call this state the Big Bang. Conditions initially must have been unimaginably hot and dense, so that even atoms or subatomic particles could not exist, and the universe began as a sea of energy. As the universe evolved, then it cooled and became less dense, and these conditions allowed subatomic particles and eventually hydrogen atoms to form. A relic of that initial energy of the Big Bang is still seen today in what is called the cosmic microwave background radiation. And if you've read the press or watched television, you'll know there's a satellite called Planck, the Planck spacecraft, which was recently launched, and it will study that radiation in unprecedented detail. This radiation shows that the early universe was almost completely smooth, but tiny fluctuations in it gave rise to structure in the universe which evolved ultimately to the clusters of galaxies we see today and to the galaxies within those clusters. Now, any galaxy is made of stars. Now, when we study a collection of stars, we see a population that, in a way, is similar to any collection of people. We see old stars, young stars, massive stars, and tiny stars, just as we would find a range of ages and sizes in any human population. This simple observation tells us that stars must form in various sizes evolve and ultimately die, end their lives, and in fact the study of stellar evolution, as it is indeed called, stellar evolution, has been one of the great successes of 20th century astronomy. We can now detect stars in the process of formation from clouds of gas and dust, as denser clumps within those clouds collapse under their own weight and become hot enough at their centres for nuclear reactions to begin. We can study how rapidly stars evolve. We can see that massive stars use up their energy rapidly and may end their lives in a few million years, while a modest star like our Sun shines steadily for many thousands of times longer. Our Sun will end its existence by evolving into a state with an expanded atmosphere that will envelop the Earth and end all life on this planet. But more massive stars, evolving more rapidly, end their lives in supernovae explosions and spread the ashes of their nuclear burning into the surrounding clouds of gas. What about planets? Well, the formation of stars from clouds of gas in interstellar space is accompanied by the formation of planets. The rotation of the gas cloud in which a star is formed tends to surround the new star with a dense disk of gas and dust. Colliding dust particles stick together and accumulate and grow eventually into comet-sized objects, which again may collide with each other, eventually evolving into planets. These may or may not be capable of sustaining life. Astronomers have now detected hundreds of planets in orbits around fairly nearby stars other than the Sun. Planets are common in our galaxy. We do not know yet whether they support life. Most of the detected planets cannot, being too close to their central stars, but some Earth-like planets have now been detected. So what is the message of astronomy? It seems to me to be this, that everything in the universe, the galaxies, the stars, and the planets, everything is evolving and everything is related. Planet Earth is formed from atoms that are the ashes of the nuclear burning that happened in distant stars billions of years ago. We ourselves are composed of those atoms. The message I take from this is similar to the message that Darwin might have taken from the idea of human evolution on Earth. We are exceptionally lucky to be here and to have the mental ability to appreciate the beauty and the grandeur of the universe. We are lucky to be here. As far as we know, we are the first species on Earth to be aware of the challenges to existence. Most evolutionary lines for species that have developed on Earth have been terminated by the inability of those species to respond to the various threats to existence. Our evolutionary line continues for now. We are the first to understand the various threats and to have the technology to meet most of them. It is surely our responsibility to evolve in our relationships with each other so that we can meet those challenges as best we can. Thank you.